Welcome to another RDWorks Learning Lab. Today we're going to start off with a little bit of smoke. Now what we have here is something which I call a mode burn. If we look carefully, that is not a hole in the bottom there. What it is the beam with a flat spot right at the tip. Now that means basically I'm cutting here with a blunt knife or drawing with a blunt pencil because it's lost its power right in the centre of the beam. Now we're going to look into this a little bit further in the next session, but the reason why I'm showing you that now is because I'm going to have to change the tube. It's a perfectly good tube that cuts extremely well, but as you can see, it's somehow lost its vital sharp edge right in the centre of the beam, and that is where I think, from all the work that I've just done recently with lenses, that we need the maximum amount of power. Now I've noticed on this machine, when I try and do my dithered photo engraving pictures, that everything comes out slightly fuzzy. It's difficult to describe, but it's not crisp, clean and black like it is on my other machine. So I've got a new tube over on the other side of the workshop there waiting to be fitted to this machine. Now it's going to be a 70 watt tube as opposed to this one 60 watts, but that really is a small issue. The biggest problem that I have is fitting the tube. I'm not in the least bit worried about fitting the tube, it's not a difficult task. The biggest problem is getting it lined up. Now this machine is typical of most red clone type machines in that the bearing rail is sitting on top of the gantry here, and that makes it very easy for them to mount the head in this very simple but unattractive way. You've just got a straight block of very stiff material across here on which you plonk the head and screw it on from underneath. Now that's extremely simple from a manufacturing point of view, but an absolute nightmare when it comes to setting the machine beam up. Now just here we've got 4 screws that fix this plate to the bearing, and this plate has got some adjustment on it this way, so we've got some Y adjustment, but what we haven't got is any Z adjustment on the head, and that Z adjustment is absolutely vital when we come to setting up the machine. Probably about 95 or 99% of all Chinese machines do not have any Z adjustment on the head. As soon as you put a Z adjustment on the head, life becomes extremely simple, and I'm going to be demonstrating that to you anyway when we set the beam up. I've just stuck this piece of card with tape over the front here, and I've marked it so that you can see where the orifice into the head is. And we'll just quickly do a quick pulse before we start. And there we go. That's, as you can see, it's approximately towards the middle of the head, but it's not exactly. So we'll turn the machine off and we'll start ripping the machine to pieces. We'll unclamp the belt this end, and we will just loosen these lock nuts off on the tensioner, and that means these should then unscrew. And there we go. Now the only thing that's holding that whole head assembly on now are these 4 screws. Right, now everything now comes apart, and what we're left with is 4 screws that hold this head onto the bracket. I don't know how much that weighs, but I'm just going to go and weigh it. Well, the answer to that question is 130 grams. Here we are in pieces. All we've got to do is put it back together again now, and we should be building it back together with my new adjustable head. It adjusts in Z and it adjusts in Y. Now there is a difference in weight. That was, as we found out, 130 grams, and this is about 180 grams. So it's about 50 grams heavier, but I don't think that's going to be a major effect on the head at all. Now the existing screws in here are, I believe, 16, yes, they're 16 millimeters long, M4 by 16. I think we're going to have to change them to M4 by 12. This plate sits on here. It's got a couple of location bars on the top there to stop this from twisting. all right, and that will slide backwards and forwards. Now, I've made, I think, one small mistake when I designed this, and that was to copy exactly what was there before, more or less. If we notice here, these screws line up with the green plastic of the wiper section on the end of the bearing. I think this probably should sit a little bit further forward without any consequence, so that I could allow these screws to pass through and sit out in fresh air, because at the moment they've got to be very accurately sized so that they don't poke through very far at all. Now, depending on your machine, we have to take this into account. We've got to allow a flag out here to cover the sensor. So that's what this sticky out piece is all about. Now, your sensor might be at the other end. It might be, for instance, here somewhere. The chances are that your sensor will be somewhere like this as well. With this style of head bracket, they usually detect on the underneath face, just here. And so there's a pretty fair chance that yours will be in exactly the same spot. Right, so operation number one will be to put the belt, clamp the belt onto this little pad here. Because I've thinned out the material here, this pad needs to be thick to allow me to put the belt in exactly the place that I took it off of. They won't fit. They're at least 2 millimeters too short, and those are 8mm screws, so I need some 10mm M3 by 10 to fit in there. Now, I haven't got any cap head screws, but I've got some M3 by 10 crosshead screws. So that's that little problem solved. While we can see what we're doing, we'll fix this piece back on. Now, you'll find that when you take this off, it's probably got 2 lock nuts on it. You don't need 2 lock nuts on there, you only need 1 lock nut. So I've dispensed with the extra lock nut. And these should be, again, these are M4 screws which should fit directly in these tensioning holes here. Okay, so once we've fitted these tensioning screws, we can tighten them up so that the belt feels pretty tight. What we're looking for is to make sure that these 2 screws look approximately the same distance. We're looking to get a fairly even tension on this belt. I've got the screws lined up quite nicely in there with the bearing block. And now I should be able to just drop this piece on here, like this. The screws that came out of there are 18mm long. Because I've used thinner material, 18mm are going to be too long. So this time what I've done, I've reduced the screw length to M4 by 12mm long. I've done the screw up fully and it's still adjustable. So 12 is too long, it probably needs to be 10. Right, we've managed to find some M4 by 10s. You just slacken off the screws a little bit. And we should be able to slide that backwards and forwards for adjustment. Now this is the head mounting bracket. We shall just remove this for a minute. And I think it'll be pretty obvious which way the head fits on. And they're the existing screws that mounted the head. Now you will find that there's a small amount of clearance at the back, just so that there's no chance that the mirror is going to jam on the back plate. I've purposely left about a 1mm gap at the front here for a very good reason, which I will show you in a few moments. Okay, we'll leave those very slightly loose there, so that we just adjust this one back screw at the back here, and we can lift this up and down, knowing that the front is not going to wobble very much. We just take that up just to take the slack out of it, just so that it slides up and down smoothly but doesn't twist. And then we can just use this top screw at the back here to set it with. So I've just caught that top back screw at the moment, and I've cut myself some large paper targets here. Now these are not designed for this particular purpose, but I'm going to use one of these at the moment just so that we can get things lined up. My bracket purposely fits the support bracket for the cable chain. The whole design is based on this plate, and there's a limited amount of places that they can actually put these fixing holes. So there's a good chance that your cable tray or your cable chain will be fitting in exactly the same way. Okay, so there's the cable chain fitted on nicely now. everything's back together. Almost. Slide this through here, between, and we need to just clamp this with a tie wrap. We can clamp that onto this tensioning screw, and we'll turn the machine on, and let's hope that the sensor is set correctly. There's definitely something jamming this table. What did I do? What have I done? Well, I think we may well have found the culprit. Welcome to my machine. If we take a look here, did you see that little teeny weeny piece of acrylic? I've been cutting some very small acrylic. A little piece just like that has somehow managed to get itself trapped in the thread there, and that's jammed up in the nut. And this time hopefully we'll find 0 in Z. There we go. So we've got the head back together. So the machine was basically set up before we started. I haven't got to worry about X. If I just bend that, it'll probably have enough resistance to hold itself in place. So let's just line that up roughly with the centre. We'll give it a couple of quick pulses. Tell you what, you can see the hole in the middle of my beam there. That's the place where there's no power. If there was power there, it would be black in the middle. Right, so what we've got to do now, roughly, quickly, is we've got to pull this out, like that. A bit more. Too much. So that's on centre. So we can just lock one of these screws up. Well, we'll just put the 2 diagonal screws. We'll just tighten them up very, very lightly, because they've got to come undone again in a minute. And now we've got to get the height right. Well, we've just got to lift this up to catch the beam. So we'll undo this one screw. And we'll lift it up. Well, there we go. I don't think we could ask for much better than that. How long did that take? A minute? Okay, so we've got the head set up approximately. All right? And for most people, they would say, that's Z set. All I've got to do is fiddle with my screws on the top here and I'm job done. Well, we know that that's not the case, because now we've got to make sure that the Z axis is perpendicular to this table. And what I'm going to do is put a block underneath here, and I'm just going to take any piece of card, I'll use one of my discs, and we're going to do a pulse anywhere, it's not important. Now we're going to drop the table down by at least 4 inches, 100 mil. Any more, it doesn't matter. The bigger the distance here, the more accurately you will set the Z. And now we'll press and have another pulse. And there we go. It's wrong. Now to correct that back to the first pulse, what I'll have to do is to undo this mirror, let the beam swing that way. And let me check it again. Maybe. So we've got it near enough. We've got to go through the whole process again now. And here's our second attempt. It is very, very slightly towards here. So we want to let that mirror go that way, so we'll let it off just a shade more. Too much, I think. I think that's pretty good. Now, because it is so easy to do, we'll just carry out one last test. So we've now got the beam running absolutely perpendicular to the table. The next challenge is to get the beam in the centre of this axis here. I've made myself a very simple little jig. that is a nice snug fit. It's a slide fit. I was very lucky with the way in which I cut the dimensions. That allows me to line this up, this little square box, with the axis of the tube. And this is really what I designed my targets for. My targets just sit in the bottom there, like that. Now, it doesn't matter where the head is now. All I'm trying to do is to get the spot right into the centre of those crosshairs. So let's do a quick pulse and see where we are. Well, there we go. We can see that we're not on the crosshair. All we've got to do is move the head backwards, and that dot will come into the middle of the target. So we just loosen those screws off on the head, and we gently move the head backwards and try another pulse. Bit more. It's not bad. I don't think I've even got to move the head up and down. I think I'm that lucky. So we just drop another target in. Do a quick pulse test. Well, I don't think we can ask for much better than that. We've adjusted things easily in this backwards and forwards plane. I'm a very lucky guy, and I think maybe I ought to go and do my lottery numbers now. They happen to come out spot on that centre line. 8 people out of 10 would say, great, you fixed it, leave it alone. No, I want to show you how easy it is to set this head up. So what I'm going to do is drop the head down, and we'll do another burn. And that's what happens when the head is out of position vertically. You can see I haven't affected it backwards and forwards. It's still on that centre line, but now I've got to get it onto this centre line. Now, this is where you might need some mental acrobatics. Look, if I put that there, in line with my mark, it's forward of the centre line, which we can see. But if it's forward of the centre line, it means that the beam is coming in and hitting the mirror too high. It's hitting down in front of the centre line. Now, by raising the mirror, what we've done, we've allowed the beam to hit the mirror lower down. And hitting the mirror lower down brings it closer to the central axis of this lens tube. So let's have a quick check and see what we've done. And there we are. Now, I hadn't got these screws tightened up on the head, so I think maybe I've still got to put a small adjustment in the y-axis to get that true now. So let me just tighten up the z-axis so that I don't get any movement in the z-axis anymore. So yeah, in a few moments when I get the machine set up, I'll show you how I produce these paper targets. So the goal of this has been to get the beam to pass right through the central axis of the lens. And that's what we've done. We've set the beam up so that it runs absolutely true. So here I've got my 2.5 inch cutting lens. Oh, before I do that, I've got to put this on. My little clamp handle that I use. Just plug in the air assist. Make sure everything's clear of the sensor at the end here. One thing I forgot to say, when we talked about these lock nuts on the tensioning system for the belt, I said you only need one lock nut. Now, that's true, because what you can do, you can either lock it onto the back or to the front. It really doesn't matter which position you lock it onto. By just locking it onto one of those positions, whichever one you can get to, like that, there we go. So that tension is now fully secured and locked. Now, I'd normally put my pin table up to cut card, but for doing lots of jobs you don't need a full pin table, and the problem with the pin table is after a while it gets a bit damaged on the surface and tends to curl up. So now I've designed something completely different, which is a flexible pin table. Here's what we finished up with. I'm using an M16 dome nut, so that's an M16 grub screw with a conical end to it, and I put that inside there. And before I fit this, I've been a little bit brutal with a hammer on here, and you can see I've deformed the thread at the end here. So that allows me to assemble this up, and I get to that point there and all of a sudden it goes very stiff. I will have to put that in a vise, and I will be able to wind that thread in, and that thread is really nice and tight. And then what I've got here is a hole that I've already drilled and reamed in the end, 2mm diameter, and I've got my 2mm dowels that I bought. And those dowels are a snug fit, so they tap in and they sit down on top of this, and then I tighten the nut up inside the bottom face like that. That one says 47.65. The next one says 47.68. So I can set these to a perfect dimension. So I know that all of those are the same height, and they now become a fully flexible pin table. Okay, so here I've got a piece of card which is a nice white card that I bought for photo engraving. Unfortunately, it's not much good for that because it's got too much china clay in it, and it produces a brown film around the cuts. So I use it for all sorts of things. This will be one of them because it doesn't matter if they've got a little bit of brown around these. I'll just get over one of the pins like that so that I can get the focus set accurately. We'll just drop the head down onto the gauge and lock it up. There we go, 7mm is what we want to make sure that it's roughly true, and I can do that by looking at the shadow pattern along the back there, and then by eye I will just put the nozzle on the corner of my paper. At first we're drawing the lines at very high speed. And then we're cutting the targets out. Now I hope you can hear how hissy that cut is. I'm running at about 4 milliamps and 35mm a second. So I'm cutting that with a very high frequency pulsing type of cut. And that's a 2.5 inch lens that I've got in there. Now if we look carefully on the back, it's more obvious. You will see why the pieces didn't fall out. They've purposely got a little tag on them to make sure that they stay in, and you only take them out like bus tickets when you need them. And then they just literally just slip in the bottom there. They're just a perfect clip slide fit. They don't fall out. Well, I think that was an interesting prelude to the next session, which will be all about changing the 70-watt tube to try and get rid of this polo burn that you saw when we were doing these targets. Well, you may or may not be able to see my breath in the air, but it's getting a bit cool in this workshop. I think until the next time, I'll thank you for your time and say cheerio. Aha! You thought you'd got rid of me. I'm sorry. In my haste to get in and have a nice warm new fresh cup of coffee, I realised that something important had slipped down between those two remaining grey cells that I've got. I forgot to tell you that I made another set of parts, and these parts are going off to China to Cloudray. Now, I'm not doing this as any sort of favour for Cloudray. I'm just trying to dump the monkey off of my back. Who knows when St. Peter's going to call me up to fix his big machine? I don't want this responsibility of manufacturing these parts. I believe, honestly believe, that there is a future in having this fitted to Chinese machines. There are so many of you guys out there with red sail clone machines that use the C-type head that I think that you should write to Cloudray asking when this adjustable C-series head will be available for sale. That may well expedite the availability of this product to buy at a price that is a Chinese price not the price that I would have to charge you. Well, this time it's for real. I'm off. I'm going to go and watch the soccer on TV. Cheerio till next time.